Hello friends, सबको नमस्ते. So today this video we will create a brain tumor classification model using a YOLO. So I already uploaded my dataset file or zip file in my Google Drive. I have to connect that. Just copy the share link and paste it here and cap this part only. It should be this much only. Okay. And paste it here and just run this cell as it is. Okay, your zip file will get downloaded. You can see this is a zip file. Now we have to unzip it. For that I have to use zip file library. And you can see this is a dataset which contain two folder, test and train, and inside this you have got two folder, no and yes. In yes it is a images with brain tumor, and no means normal brain tumor, no normal brain scans. Okay, now Ultralytics is a package through which we can download the YOLO model. Is it? And just we can upload, first we have to upload the YOLO classification model, and for that we are using model is equal to YOLO, import YOLO, then YOLO11 class split. You can see this, there are various classification model for YOLO11. We have N, S, M, L and X, and reference is of parameters. The model which we are using is of YOLO11L, who's which having 12.9 million parameters. Okay, now one more thing, that each model is trained with 224 into 24 pixel image size. So after loading the pre-trained model, we have to train it on a custom dataset. For that, just use the model.train and just give the your dataset folder name, brain tumor dataset, epoch will be 5. I already have a model which is trained on 50 epochs. So after showing the result of the model which is trained on 5 epoch, I will show you the result of the model which is trained on 50 epoch after uploading it. And you can see this image size is 224 because it's already trained on 224. It's required. Batch is 8 means when the during training when the images number of images is converted or converted into a batches. I want in each batch 8 images should be there. And this is name YOLO brain tumor. What is the mean of that? It means when you run the cell, you will see that run folder will get created, and inside the run folder detect folder will be there, and inside the detect folder one folder will be there whose name will be decided by us, and we have decided brain tumor dataset YOLO11. And inside this folder you will get one folder, weight folder, and inside the weight folder you will get the weight file. Okay, which is which will be used for prediction. Now here save is equal to true means we want to save the weight file. Now save period -1 means we do not want to save every epoch weight file. We just want to save the weight file with higher accuracy. Okay. Now patience 20 means early stopping. It means when after every 20 epoch, there will be the check that accuracy is increased or the loss is decreased or not. If it is not happening, then training will get stopped after 20 epoch, and after every 20 epoch it will cross check this. Now validation true, yes, we want to validate it, but for validation I think we do not have a validation folder, so it will be false here. Okay, cap it false. Okay, now we do not have enough you can say enough images for the brain tumor with different variations. Okay, so add the variation in the images. We have added data augmentation. You can see we are using attribute degrees, flipper, scale, shear, translate. There are many data augmentation attributes, but I am just using this ones. Okay, so after adding data augmentation on all details, let me run this cell. The training gets started. You can see it. See, it's getting started. 5 and see GPU memory means the memory which is used by the use here with GPU, and loss is classification loss. And you can see 450 here. 450 is a batch size. Okay, not batch size, batch, 450 batches there, and inside every one batch 8 images is present. Now let me explain you this thing. You can see this run folder is created by default. Inside the run folder, classify folder will be there, and inside the classify folder, brain tumor folder name decided by us, and inside that the wait folder will be there. But you can see one, uh, just wait. You can see just after completing one epoch, second epoch gets started, and when I will roll, see best and best and last, and the model which we use is best one. Okay, it because it will save the best wait file. So now we have to load the model which we have trained on custom dataset. For that, we use model is equal to YOLO, run, classify, brain tumor dataset, YOLO11, wait, best PT. Now the folder in which the images is present. And you can see that in test folder, oh, what is this? Where is content? This one. See, in the brain tumor dataset folder, you will get test, but two folder, no and yes. I already told you about the meaning of no and yes. These are the, you can say these are the class names. So test directory will be there. Then inside test directory, we have to list all the folders name, yes or no. Now, uh, I want to plot 16 images. For plotting the 16 images, there should be a 4 rows and 4 columns. So plot dot subplots, 4 rows and 4 columns. Figure size will be 16. Okay. Now for the iteration over the subplots, we are using x dot variable. It is in 1D format here. Now to plot the plotation for the plotation of 16 images, I have to use for loop for 16 times. Okay. Now, first I will select random, you can see image folders. An image folder contain the folder names, yes or no. So I will first select randomly folder name, yes or no. When I will select the randomly folder name, then I have to create the list of all the file names inside present in that particular folder. For that, I will use OLS directories, which create the list of all the images present in that particular folder, random selected folder. Okay, for that just give OLS directory folder which create a list. Inside the list we have to give the path name. For that, just for that we use os.path join. Test image folder means this one. Inside this folder, inside after that I have to give the folder name which is randomly selected. So for that we use give this variable. When this whole thing first create the directory through which we can create the list of file names present in that particular folder after selecting the random folder name. Now after creating the list of this, we will select the we will create the image directory so that we can read that particular image. For that we use OS pass name, just pass the image name, then the image folder which we have randomly selected, then random choice of image files means the list which we have created from random. Then we have to select the randomly select a file name through this. Now then we have to read the image. Okay. Okay, now see, just pass the image path. It is either you can pass the direct image after reading it, or you can pass the image path. There is no error will be occur. Both will be remain same. That means no error will be there. Both will be okay. It's up to you what you will do. And just wait for a minute. It can be converted into this. Okay, it should be like this. There is no difference, but like this. Okay. Now it should be result, not result. See, what is the use of this? It just pass the image path or the image direct image. And what is the use of zero index? Because just we are passing only a one image, so we want only the zero index value, zero index results value. So just pass the zero here. You will get the passing image predictions values. After getting the result, we have to what we want to know the class ID, whether it is 0 or 1. On C, on 0 you will get no as a class name, on 1 you will get yes as a class name. Okay, now after getting this, just you have to use a class name. Then you have, after getting the class ID, you have to know which whether it is no or yes. For that, just use in model.name class ID. Then we want confidence also. Just use return result.props.top1 confidence.item. You will get the result of that. Now after that, you can see that we have read the image into BGR format using our CBT. So we have to convert that image into RGB. So we are using here RGB here. After converting it, we have to plot that image. Then we have to set the title, that actual means the folder name decide the actual prediction. So we use actual prediction that are predicted by the model. Then we have to display the confidence. So for more clarity, let me print everything. Print result here. You will get everything what we are doing. And one more thing, that print model dot names. Okay, you will get everything what is happening here. So, and let me print the break here. Let me see that our training gets completed, so we can use it. See, image folder, no such. Oh, sorry, I think so. There is no folder name with dataset. Now let me run it. See, this is boxes detail, means bounding box details, you can say, or anything else. Key points, mask. You can see the model.names. In model.name, you can see that's 0 index value for no, and 1 index value for the years. Or this is the original image, original path, props. You can see props are the props through which we can give the we can get the details. Okay. Now speed, props, inference, processor, everything is there. And you can see we have inside the prop result will be there. Okay, inside the prop result will be there. So how we can get it? You can see I let me print the result dot props. Okay, so we can get the information about that. See, inside the result.prop, you will see that it's equal to data, original shape. Top one will be the confidence. You know, not confidence, class ID. Top one confidence will be this 0.998. Okay, so this is showing that for the no class level, the confidence will be this one, and for the years class level will be 0.99. So it's showing this, and we want the highest confidence, so it should be top one confidence will be this. Okay, now see this one. See, model dot name simply will be this one, means 0 for the no and yes for the 1 for the yes. So this way we retrieve the information from this result variable. Now let me show the result of 16 images, means the model which is trained on 50 epoch. Let me show the result of that, how it's working. See, no, pretty good, yes. Let me count a mistake first. Here, one mistake. Oh, in 16 image, according to this, among the 16 image, one image will be one prediction will be wrong. Now let me. It's pretty good. Pretty good accuracy is good. Now let me let me upload the model which is trained on 50 epochs. Okay. Let me come back when this uploadation will get completed. Okay. So my uploadation is completed. So let me show the result of the model which is trained on 50 epochs. You can see, I think so there is no error. Yes, no. Yeah, yes, no, yes, no. Oh, this is one mistake. And no mistake will be there. Okay, means better accuracy. Both are working very good. Either you can train it with 5 epoch or the model which is trained on 50 epochs. Both are working good. Okay, so this is a YOLO model for the classification purpose. Now you can use it anywhere you want. Okay, so please like, share, and subscribe. Thanks to all.